Hi, I'm Oni, and I'm part of two IIT alumni who post daily videos on math and physics on our YouTube channel, Mathophy. Let's get started with our JEE problem. Okay, so today we'll be doing sums on advanced transient circuits which involves capacitors and resistances. These kind of sums are very important, especially for your JEE Advanced. So the first question says that a resistor R and 2 microfarad capacitor in series is connected through a switch to 200 volt direct supply. Across the capacitor is a neon light bulb that lights up at 120 volt. Calculate the value R to make the bulb light up 5 seconds after closing the switch. So we know that the maximum voltage that the capacitor can take up is 200 volts and the voltage that it needs to take up is 120 volts. So we can write the voltage equation for across a capacitor for charging. V is equal to V naught 1 minus e to the power minus t by CR. So at any instant time I can find the voltage. Now let's put the values in. It says that this V should be 120 volt, putting 120 in. The V naught maximum voltage should be 200 volts. 200 1 minus e to the power minus t by CR. So t is given as 5 seconds and C value is given as 2 microfarad and R I'll put the values in later. Expanding this and doing some basic arithmetic calculations, we find that 120 is equal to 200 minus 200 e to the power minus 5 by CR, or e to the power minus 5 by CR is equal to 200 minus 120, that is 80, divided by 200 that comes in from here. We can cancel this out and I'd be left with, this would go with 4, this would go with 2 and this would be going with 5. I'm cancelling with 4. Now I can use the ln function, the natural log on both sides. That would give me here minus 5 by CR is equal to ln of 2 by 5. Bringing the negative over to that side, we know negative of ln gives me just the reverse of this. So 5 by CR is equal to ln of 5 by 2, so ln of 2.5. Now we have been given log base 10 of 2.5, that is 0.4. We have it as a natural log, so to convert it we can make it 2.303 into log base 10 into 2.5. From here it is easy to calculate R. We have R is equal to 5 divided by 2.303 into the log base 10 2.5, that is 0.4, into your capacitance C, that is given as 2 microfarad, so multiplied with 2 into 10 to the power minus 6. We can evaluate. We have to use a basic approximation techniques here. Let's treat 2.303 as 2.5. 2.5 multiplied with 2 would give me a 5. 5 into a 0.4 would be giving me a 2. So again I get 5 by 2. That would come to approximately 2.5. Let's make this approximately 2.5 into 10 to the power 6. So the nearest answer to that is 2.7 into 10 to the power 6. Hence we deduce that option number 4 is our correct option. Let's move on to the next sum. The second sum says that a fully charged capacitor C with initial charge Q0 is connected to a coil of self-inductance L at t equal to 0. The time at which the energy is stored equally between the electric and magnetic field is. Now we know that the time period of an LC oscillation is 2 pi root over of LC. So you may be tempted to think it would just be half of that, but it does not vary as I. So let's see how we can go ahead with this. We know that the power, let's take the power of just the inductor for instance. So the formula for power of an inductor is half Li square. At any instant when the current is I, this is the power. We want to find it when the power is half of the maximum value, that is half L I naught square. So we need to find the time here. We can cancel out the half and the L from both sides. So I have I square is equal to half of I naught square. I depends in a LC oscillation, it varies as a sinusoidal or a cosinusoidal function, so we'll keep it a sine function for now. So I naught sine of omega t whole square is equal to half of I naught square. I can cancel the Aronoid squares on both sides. So I have sine of omega t is equal to 1 by root 2. That means omega t should be equal to pi by 4, or t should be equal to pi by 4 into omega. We know in an LC oscillation omega is equal to 1 by root over of LC. So we put that in here. So we get t is equal to pi by 4 into root over of LC. So correct option is option number 3. Time for the next one. This is a question that appeared in IIT 2005. It says that a capacitor is discharging across an RC circuit, and you plot the log I versus time graph, and it gives you this dotted line over here. Now they have said in the question that now you double the resistance, you multiply the resistance by 2. Which plot line should it take? Should it be P, Q, R, or S? So let's first find how we get this curve. We know that in a decaying circuit, we have I is equal to I naught. Since it's a capacitor, we have Q is equal to Q naught e to the power minus T divided by RC. If we differentiate this, we get I is equal to Q naught by RC into e to the power minus T by RC. We know we'll get a negative sign here. I'm ignoring that because we'll be using log functions. So log of 10 base I is equal to log of base 10 Q naught by RC into minus of T by RC into 2.303. So I used a natural log here in the beginning and then just put in this factor here to convert it to a log base 10. So now if we look at this equation, this gives me a straight line equation for log I base 10 with respect to t, where this is your y-intercept c and this part over here is your slope m. Now we see that if we multiply the resistance with 2, if we increase the resistance, the y-intercept goes down. That means of these 4 lines, it has to be either P or Q because its y-intercept is below the original line. The next thing to see is the slope. Once again, we see that in the slope, it is a negative slope that we can see in all the graphs here. We can see that if we increase the resistance, the slope goes down. Slope going down means the line becomes flatter. So it had to be one of these two. Now I know it has to be the flatter line. So it will be number Q. So correct option is option number 2. That's it for today. We'll see you again in the next video when we go into AC circuits. Like, comment and subscribe to our YouTube channel Mathophy for your daily dose of math and physics.